and today's video will be 3D printing a sword. This is a sword that I modeled and sculpted myself. If you want to know how to do that yourself, lucky for you, I just made 2 tutorials on that. I'll put the link in the description. If you want this particular sword, or the one that I made in the last video, or just to support the channel, I'll be putting them on Gumroad. Link in the description for that as well. Without further ado, let's open up Blender. Inside of Blender, to make things easy for yourself, go to your scene properties and set your unit system to metric or imperial, whichever one you actually use. And if it is metric, you're going to want to change it from meters down to something like millimeters. Here is the actual sliced version of the sword that I printed. And effectively the way that I did this was I made a measuring cube, and I just went and did a Boolean, 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 and went across it that whole way. And then I added some dowels, 6 of them to be exact, and all of them are the exact same size. I Booleaned them out into the blade pieces, and I scaled them down slightly so that with print tolerances they would fit nicely and not be too big. The bottom of the blade got Booleaned into the crossguard, just like the top of the hilt got Booleaned into the crossguard there, and the same thing with the pommel being Booleaned into the bottom of the hilt. So this is a really easy 3D print only way to do it. If you were going to be extra smart, what I would do is actually buy a real dowel or threaded rod or something that you could put all the way through it, like so, slice it up the same way, but just have one hole in the middle that everything gets glued to. You could also maybe make some interlocking pieces for your slices in between the blades, like so, right? Kind of have a dovetail type deal going on, but less funky than how I drew. That would help you line things up for gluing, and it would provide a little bit more surface area, which would make the joint stronger. However, it would also require a lot of support material and cleanup. So instead of making an interlocking joint that way to keep things in line, the 2 dowels made sure that I was gluing everything up without having any rotational issues. So I'm going to show you how to slice with Booleans in Blender, but before we get to that, the first thing you want to do is make sure that you have appropriately scaled your piece to a real-world size. In this case, my printer is 220 millimeters by 220 millimeters by 250 millimeters, and so the largest piece that I wanted to do as a single one was this crossguard, which is currently, you can see, set to 269 millimeters. The maximum diagonal I can fit, just, you know, staying pretty flat, not accounting for rotating upwards on the print bed, is 311, so I kept that within size. If you don't see this panel on the right, all you have to do is press in and then go up to item right there. And if you're working in imperial, again, you can go to your scene properties and change the scale to imperial. Before you start slicing, you're going to want to save a new copy of the file so you don't damage your original. Press Shift Control S or go to File, Save As, and just put in a new name. I'm going to write Better Sword Tutorial Slicing. Now press Shift A and go to Cube, and then you can change the size immediately here, but if you click away and that goes away, no sweat. Just go up here, press in to get to your items panel, and then you want to change the dimensions to either your print bed size or a little bit smaller so that it's easier to kind of line everything up. I'm going to go a little bit smaller. I'm going to go with just... Actually, I'll go 220 because we're going to do these pieces vertically. So we'll just do 220 by 220 all across. Now let's go to our top view, and we're going to pull this down so that we get the tip of the blade. Now, you're gonna have to be aware Boolean something with this many polygons and faces, triangles, we have, you know, 3 million, over 3 million faces here. So it is gonna take a little bit. Your computer's / Blender is gonna maybe pause for a second. Don't panic, that's normal. If it lasts, you know, 4 hours, call a doctor. Now, what you want to do is you're actually going to select your blade and do Shift D to duplicate it. Select your blade, your new one or the original, it doesn't matter, they have the same geometry. Go to the Modifiers tab and search for Boolean. Now you're going to want to change this to float as a solver because it's a little bit faster and it should work. If it doesn't work for whatever reason, try exact, try manifold. I'm mostly doing float because this is on video, and even on float, Blender is going to pause for a little bit as it calculates this because it's such high geometry. Select your cube object that we're using as a cutter. And this is currently set to difference, so what it's going to do is cut off the tip of the blade using that. So we're just going to press Control A to apply that modifier. And again, it'll probably freeze a little bit. There we go. And then we're going to select the other piece, the one that we can see is still a full blade. We're going to go to Modifier, Boolean again. Let's switch it to float again real quick. We're going to change this one to intersect, and then we're going to select the cube again. Excellent. And then we're going to press Control A to apply that. And then if we hide our box, that is by selecting and pressing H, you can see we have our first sliced part here. Now let's unhide our box. You can do that either by pressing Alt H to unhide everything in the scene, or just going into the hierarchy over here and showing it with the little eye icon. Now your next step is simply to pull this down. You don't have to be necessarily the most precise with it. You want to make sure that you actually have it a little bit above our seam. If you don't line it up perfectly on that seam, or even if you do line it up perfectly on that seam, it can cause some issues with the Boolean. And then you just repeat the process going down the blade. In this case, you know, we would get one here, and then we would manage to slice it, I think, one more time, right? 220, oops. 220 roughly, yeah, you'd get one more slice and then we'd be left with this one little piece of hilt there. And you might even choose to make it a little bit smaller if you don't want to have a seam on your ornamental area. Now, when you're doing the Boolean for the blade into the crossguard, it's a little bit easier. You don't have to duplicate anything. Just add your Boolean modifier, keep it on difference, select the blade, and once it has succeeded, just press Control A to apply, and then do the same thing for the hilt. Another Boolean, set it to float again, set it to the hilt, and Control A, and ta-da! Now you might actually want to, before doing that, you can see how crazy shallow that is. And what I did on the one that I did print was I extended this a good amount into the blade so that we'd have a much better hold. So I'm just going into edit mode, going into vertice select, pressing O for proportional editing, and I don't want it too high, and I'm just gonna drag it in without distorting that little ring detail I sculpted in there. And we're gonna pull it over more towards the middle there. That should give us ample space. Something you could do if you wanted to, I know that it works like this, that these are straight edges, but to make things easier, you may choose to actually taper things inside so that they fit a little bit better. If you taper it outside, of course, then that means you're not going to be able to put it in. So if there is an outside taper, make sure that it tapers inside. So now when we go back, you can see that we have a much deeper hole that we're going to be able to put the hilt in and glue up with a ton of surface area to make it really strong. To make dowels and the insertion point, just go ahead and press Shift A, cylinder. And then you're going to want to scale that down a lot, and you're also going to want to scale it down excluding the Z-axis. That's Shift Z in scale mode. Let's bring it over. Let's rotate it 90 on the X-axis, and that's definitely hidden in the middle. Let's bring it over to the sides, and let's scale it down a little bit again, like so. And yeah, that should be good. So we're just going to press Shift D and click, and then we're going up to our transform panel here, and we're just going to change the negative on the X to a positive, or if you would put it in the positive position, vice versa, make it negative. Now let's hide this part of the blade. Let's select our tip here. We're going to do yet another Boolean. This will be a difference Boolean. And we'll select that cylinder, apply it. We'll go to Boolean, difference, cylinder, and apply. And then if we hide those, you can see we've got our holes. Do the exact same thing for the other side of the blade, and then make sure to scale them down. Unless you have a really, really precise printer, you're gonna have to do this at around these sizes. So I'm just pressing dot here, period, and going to individual origins. And then you can probably eyeball it if you want to try that, or you can give it a specific value, like say 0.9. That might be too big, or too big of an opening. 0.95, you should be okay, right? And you know, if these dowels end up being a little bit too big on your printer, they're super tiny. They should print pretty quick to make some replacement versions. And just do that for any, sliced pieces that are straight that won't fit on the printer, and you're set. The last step in Blender, once you have sliced up your entire sword, is to go to File, Export, STL, and you just name it whatever you want and click Export STL. Now open up your slicer of choice. For me, that is Orca slicer. For you, that might be something else. It kind of depends on what printer you have and what it works with and everything. So here's the actual file that I used for the sword that I printed that you saw at the start. As you can see, I've just aligned everything the best I could get it to fit in there. I do think maybe there's like a little bit of nuanced stuff I could have done, like if I put all of these slightly closer, then there would have been slightly less travel time for the print head, and maybe it would have sped it up by a few minutes. I don't know. It ended up being, it estimated a 15-hour print, but it only took 13 hours. The only extra settings I had was precise wall. I kept my, I put it at the finest settings that I could, and I did a couple more wall loops, and I did a sparse infill pattern of adaptive cubic, and of course I turned on supports. Speaking of supports, one issue with the way that I did this that wasn't necessarily a huge issue for me, but you might find annoying, was with the dowel holes on the bottom, those fill up with supports. And so I had to, get that out of there, and that was a bit of a pain. I kind of did a combination of, pliers, and for some of them I ripped off the top part and there was still some stuff down there, so I used a drill and managed to get it out, and it worked out okay. But that's another reason why that other method with one big long dowel of wood or threaded metal rod or whatever going all the way through would be better, because then you could have holes that just go all the way through your print and completely fill it, and you wouldn't have to remove any supports from the bottom there. So Just to show you the basics of setting it up in Orca Slicer, I'm just gonna start a new project here. I'm gonna go up to Add up here, and I'm gonna select Better Sword Sliced, and it'll take a little bit to load, and it's gonna pop up this error message, or at least it always does for me, saying that it's too small and maybe in meters or inches. Do you want to scale to millimeters? Click yes. It doesn't mean you did anything wrong. Orca Slicer just does that, and you'll see like it's fine. So from here, what you want to do is do split to objects, and it'll freeze for a little bit, but it should split everything up. And then you can arrange all objects, and let's see, we'll allow rotate for arrangement. So arrange, and it's gonna try to put everything on a separate plate. I don't get down with that. I think that's some stupid ass shit. So what I do instead is I just rotate everything back the way that I prefer, 90 on the x-axis here, and then we can move that over real quick, and you know, so on and so forth. I think you get the idea. You just put everything the way you want it. So the crossguard would, you know, print fine with less support like this, but the problem is all the support on the bottom is going to completely ruin all of the sculpted detail. So you want to make sure to rotate that. We'll just reset the rotation to make it easier, and then we can do our -90 and 45Z. And you know, this is going to take a good chunk of support material, but in my opinion it's worth it to preserve the detail. Depending on your own sword, you might have a different opinion on that if you say put it pretty blank there. And the same thing for the pommel. If it prints down like this, then a lot of this is going to get pretty like squished and messy. So I just did the same thing with that, you know, rotate it to stand up on its bottom like that. And as I recall, this one didn't even really barely need any support material. It kind of worked out well with the way overhangs and all work. Once you're happy with where you've placed everything, go to the preview section of Orca Slicer. And if your sword is also really high poly, it's going to probably take a long time for it to finish slicing it. But once it does, you can just check for any weird errors, any messages that pop up saying like, hey, this isn't supported or whatever. And you know, you can go through and just check out all the layers if you like. It's fun. And if you're happy with it, you can click export G-code file, and it'll give you, based on the name of it, it'll have a little estimated time for the file there, and then you just click save, and you take that, put it on your printer, and print it. Easy peasy. It's also worth mentioning that if you have your 3D printer set up on your network, you can go to device here and you can export it from here. I don't, so I just export it into G-code and I put that on a USB file, and then I take it to the printer. And after a little bit of assembly with super glue, some sanding, and some painting with cheap paints, we have the finished product from the start of the video. You could definitely do a better job with the finishing process. This was just what I had on hand and didn't have to spend money on. But yeah, there you go. That's the video. I hope you enjoyed it. I hope you learned something. Like, comment, and subscribe if you want more content. And I hope you have a beautiful day or night. And yeah, bye-bye.